Welcome to the Microsoft Federal Science and Research Summit. At Microsoft, we take seriously our mission to empower every person and organization on the planet to achieve more. Perhaps nowhere is that more evident and important than the work we do to support research that helps the greater good. We push ourselves to be the best partner possible to public, private, and academic institutions. Our technology helps to serve as the backbone to the life-changing research being conducted by scientists across the globe and high above in space. Over the next 3 hours, we will be joined by Microsoft program managers and engineers, along with scientists from NASA, NOAA, the Department of Energy, and university partners, as they discuss ethics in machine learning, the need to ensure accuracy of and access to large sets of scientific data, and how technology can be the tool to understand and preserve our environment for generations to come. Our panelists are open for questions. If you have a question, send it via the chat feature in this team's live event, and we'll ask it, time permitting, of course. As a reminder, tomorrow we will host breakout sessions. If you have not yet registered, make sure to visit aka.ms/Fed Science Summit Sessions and tune in tomorrow for our breakout sessions. We start our day of learning with a fireside chat on how public-private partnerships are bringing together like-minded people and institutions to tackle issues related to national defense, scientific breakthroughs, and protecting the environment. Joining us are Eric Horvitz, Microsoft Technical Fellow and Chief Scientific Officer, and Cheryl Ingstad, Director of the AI Technology Office at the U.S. Department of Energy. Eric, Cheryl, take it away.
Well, thanks, Romanita. It's great to be here today. I'm Eric Horvitz, the Chief Scientific Officer at Microsoft. I'm here today with Cheryl Ingstad, who's Director of the Artificial Intelligence and Technology Office, AITO, for the Department of Energy. And we're here to kick off a Federal Science and Research Summit over the next 2 days that's going to bring together leaders from federal agencies, academia, and industry to reflect about the progress of science and progress with building out and securing our infrastructure, all aimed at advancing the health and prosperity of our nation. So the key themes being focused on are advances in the fast-moving area of AI and high-performance computing. And we're thinking of really reflecting about directions in this area, the promise of computing technologies more generally in achieving our goals. Cheryl, it's great to have this opportunity to have this time together, and I've enjoyed our conversations to date. I'm happy to share one of our conversations publicly with our guests today. Can you say a bit more about yourself and the role in your new office at the Department of Energy?
Sure. Yeah. So first of all, thank you for inviting me, Eric, and I've really been looking forward to our chat here today. I'm the new inaugural director of the AI and Technology Office at the Department of Energy, and we have such a wide range of AI activities, from the research and development to also the delivery and then the application of AI across the entire organization. And a lot of it is done through public and private partnerships as well. So we're not just focused on creating this new technology, but also in how do we deliver that to the broader society, and how do we deliver it to the economy through these partnerships.
So one theme of the summit is the value of, as you said, public-private partnerships, more generally bringing government agencies, industry, and academia to the table to think deeply together and work together on addressing critical opportunities for our nation in science and technology, and with leveraging the technology for the health and vibrance of the country, as well as for national security. I've enjoyed hearing and learning about the challenges and opportunities in my own service over the years on advisory boards at the NSF, at the NIH, DoD, and my latest work with the National Security Commission on AI, the NSCAI, which is a congressionally appointed committee that I've been serving on over the last couple of years. My sense is that there are great synergies and learnings to be had and much to gain from bringing folks together. This is especially true with sharing the latest in machine learning, grappling together on the use of large data sets, and coming together around rising compute needs to really get the most out of these new kinds of algorithms that we're pursuing. As one example, I've been deeply involved in helping to pull together, working with colleagues, large technology companies, along with the national labs in your organization and other organizations, to create the COVID-19 High Performance Computing Consortium. It was really fabulous to bring together multiple computing resources to make available tens of thousands of computing cores to address hard COVID-19 challenges. And as we speak today, those computers are spinning with hot cores as we speak, going up against novel SARS coronavirus. Do you have thoughts, Cheryl, on public-private partnership possibilities?
Yeah, absolutely. And the HPC consortium is just a stellar example of one, right? And it's something that we do very naturally here at the Department of Energy, is create consortia, other types of partnerships. You know, when I got here, came to understand all the different varieties of partnerships that we have as well. You know, strategic partnership projects, a whole, you know, all kinds of different ways to contract with universities, nonprofits, private sector, in order to accomplish some type of a scientific or a technology objective. So I think the HPC consortium is a fantastic example. Another one I'd like to highlight is actually one that we're doing with Microsoft, which is First Five. And so First Five is really about delivering AI tools to first responders. And, and we know with the wildfires and the floods, just how important, and this is what first responders tell us, is that the first 5 minutes are critical for their reaction. And when I think about AI, I think about acceleration, I think about speed, and I think about information, so that the right decisions can be made in real time. And so that's what we're doing with First Five. Microsoft is and Susie Adams from your company is the co-chair with me, with our office. And then we have about 14 other members and growing. And they are really nonprofits, they're universities, that's other private sector companies, and everybody really teaming and bringing together the best of what technology they can offer in data and compute, right? So when I think about AI, I think about the compute part, which you just mentioned, and why HPC is just so critical, because the sheer volumes of data. I think about data, and not only the massive volumes, but the quality of it. How important to have high quality data, and then to have the AI algorithms as well to make sense of it. So I think First Five is a really great example of that.
Yeah, I mean, I did my dissertation work on real-time, time-critical decision-making in high-stake situations. I love the opportunity to think deeply about having automation, data, machine learning as core technologies to augment human decision-making in the first 5 minutes, the next 5, and so on in crises. So as we've discussed in the past, we're at an inflection point in AI with our, indeed, recent leaps to learn from data. I've been way excited about these new abilities we have to do diagnosis and prediction, to harness advances in areas like machine vision, natural language understanding, reasoning and planning, robotics. These technologies have such a great amount to offer people in society, whether it be healthcare, climate, sustainability, national security. It's great to see quite a few efforts, quite a few centered in industry, on new kinds of tools that we say we're building to democratize AI, to make the technologies more available and usable. Some of the work going on is building out cloud computing, cloud resources, but others take AI to the edge. And of course, we want to consider the mix of cloud and edge computing, which will be important approaches to building out more efficient, sustainable, and resilient foundation for systems like energy systems in our nation. I know you're thinking a lot about edge as well.
Yeah, that's actually really an important part of our strategy too, as we look at what kind of projects do we want to promote and coordinate on, and bring, our fundamental role is a coordination role across the entire department and 17 national labs. The importance of edge computing and being able to work on large data sets at the edge, and 5G enabling that. And so when I look at industries of the future, 5G is one of those five industries of the future that we really want to promote. And then I also think of another one of the five industries of the future, which is manufacturing. And there, you can really see this this connection between bringing, 5G edge computing to manufacturing, and how it will really transform our manufacturing base. I mean, to bring the data to the edge there so they can make real-time decisions. I think of mass customization being made extremely easy because there's no people in the loop trying to do changeovers and all that. It's just all through AI algorithms and through managing massive amounts of data in real time. So I think that it really has the power to transform our manufacturing base. And I also think about this materials development. And this is something that's really important for our country, and that is a national security and an economic security issue, is materials development and our supply chain. So whether it's rare earths or other materials, we can now do this with AI and, again, high performance computing, because the massive amounts of data that we're working with. But it's really about solving chemical problems and deciding, of all the materials out there, what type of performance characteristics do you want? So therefore, what material will you create? And what is the best way to create it? What processing, what kind of a process do you need to create it as well? And our national labs are well on their way to working on this issue. Argonne National Lab has just expanded their materials development research facility there. It's really impressive. So I think that bringing edge computing will really help in that aspect too.
Yeah, just speaking about your labs, I've just learned so much about the labs in my work with the HPC consortium on COVID-19. So impressed by these compute resources that the national labs have, like Summit and so on. It's just really, really inspirational. Even for someone coming from Azure Compute and our massive cloud compute, seeing what the laboratories have had over the years is fabulous. Some of our first discussion going back months was on data and its availability. Data is often said is the fuel of today, the modern AI methods. And so coming up with strategy, directions, various approaches for collecting or generating data is going to be real important. However, when we come to data and thinking about data and people and data about people that might be useful in work in AI, it's clear we have to work with care, being ethical about data uses, having proper disclosure and consent when personal data is used, and also coming up with new computing methods that allow us to learn from data while ensuring privacy, such as learning from encrypted data, computing in a confidential manner. I know you've been thinking a lot about this also. Some of our first conversations were on data sets and data access, including federal data sets.
Yeah, this is actually really important. Like I was mentioning before, this, how important compute is, how critical algorithms are, and then the importance of a significant amount of data and high quality data. So, that's something that, as the federal government, and I think of one project that we're working on, which is COVID Insights, where we are bringing together the data that the Veterans Affairs has, and also HHS, bringing all those massive health data sets together into a secure data enclave at Oak Ridge National Lab, where we also have the algorithms. So we have the data scientists who are experts at developing the latest algorithms to apply to it. And we're co-located with Summit, which is our nation's fastest supercomputer. So, we're able to bring all three of those components together in one place with the security of a secure data enclave. And this is something that the American people would expect, where, in a crisis, how do we look at what data the federal government has, and how do we bring that together in a safe and secure way? And I can tell you that there was just extensive work done to review all the privacy regulations, all other laws governing health data, to do this right with all the right data sharing agreements and so forth. So it really an impressive, an impressive start here. And then when you have those components, now we can go forward and do some extraordinary data mining and come up with some novel insights.
Yeah, especially in healthcare, it's been such a long-term dream. I often have called AI the sleeping giant for the future of healthcare. Ever since my PhD work in the late 80s, I've always in AI medicine, I've been so excited about the prospects, and it's gone kind of slow to this day. And I'm hoping for a blossoming in this direction. And it's going to take really addressing this balance between privacy and data access. Data has been so scarce in healthcare. I think we can do it while ensuring privacy. And I'm very hopeful there that we'll have some innovations there, both in the technology that enables this, but as well as thinking through policies and programs that really break down, I would say, needless barriers to working with data in healthcare while assuring privacy to individuals. So I've been quite passionate about the prospect of bringing the fruits of AI advances to people across the country and world. I mentioned democratizing before. We certainly can lower the bar to access by providing new kinds of usable tools, tool chains, more compute, making compute less expensive, more ubiquitous, edge computing, making data sets available. But it's pretty clear we also need to bolster education and training and programs that retrain folks who want to get into the business of leveraging the most powerful algorithms and tools of our time, so that they can participate and contribute. You and I have talked about the urgent need to enhance training to build out our workforce in AI. It's a big theme of our work on the National Security Commission on AI in terms of thinking about assuring the national security, economic security of our future, and a long-term wealth and flourishing. And we have outreach programs and training in AI at Microsoft as well. I know you're thinking a lot about this at DOE, so I'd love to hear your thoughts, Cheryl, on training.
Oh, yeah, that is really a critical part of our strategy. So, you mentioned data earlier, which is also an important part of our strategy as well, which there we're really focusing on how do we make data available and AI tools available across the enterprise and share those. So one part of one lab develops a great AI tool that we share it, and the same with the data. And then if we go, continue and look at, well, how do we train our people so that they recognize the value of data, and so that they also understand what other data sets they may have access to and should bring into whatever their specialty is, whether it's business operations, running, the finance aspects, the human capital, or whether they're in one of the labs and they're a nuclear physicist. What data set should they have available, and what AI tools could they tap into? And I think that's where training becomes so important, that what we want to do is develop training courses that are multiple level, also target different specialties, and ultimately create career pathways as well for AI professionals. Because one thing that we've heard is that the nuclear physicists, the biologists, the chemists, they really want to do that job, and they don't want to manage their data sets, and they don't want to spend a lot of time coming to learn Python so that they can run algorithms themselves on their data. And to do that, we really have to look at what is this new workforce structure. If AI is going to be a critical component of how we do work in the future, then maybe we need more data managers at the operational level. Maybe we need more data scientists assigned to certain teams, and also, I think you mentioned earlier, high performance computing. How do we bring that edge closer to them so that they can access the high performance computing when they need to?
Yeah, I'd like to get back to the topic of energy, sustainability, carbon, and climate. I know we've talked about this before in our own conversations. The famed Harvard biologist Edward Wilson E.O. Wilson once told me at a seminar on AI. Actually, he walked out of this seminar shaking his head. It was a seminar on AI and the environment. He said he believed that AI methods broadly might indeed be the only hope we have for ensuring the flourishing of life on the planet going forward, given the environmental challenges we face going ahead per the trends. There are incredible opportunities. You mentioned a couple before in material science and core chemistry being aimed at opportunities like carbon capture, looking for new magical methods to grab carbon out of the air, efforts in efficiency and conservation, new approaches to power generation, even new approaches to data centers. They're taking a larger and larger footprint on energy on our planet, like our Project Natick exploration of putting data centers under the sea, using the water for cooling and new sources of energy that come in novel ways in a sustainable manner. I've looking at over the program sessions at the summit over the next couple of days. We'll be exploring uses of AI and high performance computing and opportunities with sustainability. It's a session coming up today. I know you've been excited about leveraging AI in the future, about how we generate and distribute power, the future of the grid, the link to renewables. I'd love to hear your reflections on this.
Yeah, well, a very exciting subject, and I think again, AI will be absolutely critical to the development of these new energy sources and addressing CO2 in the future, and also to managing electricity demand. So let me just touch on a few of those. So I kind of set it up before talking about materials development, and that's also how we could address CO2. And actually, AI is being applied in our labs right now to the problem of carbon capture, so that capture CO2, utilization. How could we turn it into a different chemical structure that we could use almost just in a renewable way? How could we break it down into something less harmful? How could we also store it? So carbon capture, utilization, and storage, as we refer to it. But AI will be absolutely critical. And back to this term I mentioned, I see AI as an accelerator, is that it'll make it faster. We could go at this in a traditional way, but it would take a long time. AI will accelerate it. So definitely with regard to carbon capture, utilization, and storage. And then when I think about renewables and how you have sun and wind sometimes, but not all of the time, and then battery storage. So you have to store that power in between. And then it becomes complex, right? When do you draw down from the battery? When do you pull from these other power generation sources? And maybe in between, it's a hot day and you need peak demand. And where the energy, where we're going really is to step back from requiring peak power. It's very expensive. But the way to do that is AI is going to be critical because it gets so complex, and that's on the generation side. Now think about the demand side, and this is where we have the power market administrations in the Department of Energy that produce 10% of our electricity for the nation. A lot of people don't know that, but they've really told me that if we're going to really have an efficient grid, we're going to need to also control at the point of consumption. So we're going to have to control demand. And this gets back into a lot of the things we just discussed with edge. And we're going to have to do a lot of analysis of data at the edge to understand what power is in what battery, that we could take and put back on the grid. What power is, how could we reduce the power usage, right? Maybe in a home, in a commercial, in a commercial building, that by agreement, we can reduce the temperature by a few degrees. And these are you can only, it becomes so complex, you can only manage it with AI. So It's very exciting future that we're going into.
Yeah, very, very exciting. Just thinking in detail about how we take some of our most powerful, sustainable sources of power, like wind and solar, are intermittent by their very nature, and weaving together intermittent sources with some of the traditional sources in an effective way, um, where we build systems that really give us more power uh, uh, with less carbon footprint is a fabulous direction. It's going to take really fine-grained controls and optimization and new kinds of systems and policies, I think. The other comment that came to mind as we talk about materials is this really interesting direction, which I would say is at the intersection of directions in biology and material science with synthetic bio, as we call it sometimes, is coming together with AI in ways to think through details of how we can actually redesign or design new kinds of biological systems that can grab carbon out of the air in new effective ways. In fact, I'll be having a call later on today with some leaders in synthetic bio just on that topic. I'd like to turn now to I know an area that you and I are both passionate about: responsibility and ethics with the fielding of technologies. You know, with great power comes great responsibility, as said by a very renowned sage. I think it was Spider-Man's uncle, is the source of that saying. But AI methods are in many ways the first computing technologies to start to edge into the realm, what I would say is human intellect. They're starting to be used in roles where people have been relied upon since the beginning of civilization. And I've been spending a good chunk of my effort these days thinking through with colleagues and organizations the issues, the rough edges, the directions with safe, ethical, and responsible development fielding of AI technologies. I've been chairing what's called the line of effort at the NSCAI on ethical and responsible AI. But more intensively, my work at Microsoft has been around a committee and efforts in responsible AI. The committee is called the Ether Committee, and some new offices that it helped to create in this realm. There's a real commitment to fielding technologies that align with a set of principles that we take deeply to heart. At Microsoft, we say our principles in AI are fairness, inclusiveness, transparency, privacy and security, reliability and safety, and accountability. We have 6 principles. And we try to work hard to align our product development and sales along these lines, and have lots of discussions, and even gate technologies at times that we think are not ready for prime time or are dangerous, will be used inappropriately. So there's much to do in going from principles to tools, methods, and policies. It's been great. I know we've had a great time sharing our work, as well as learning from other efforts in government, like the work we do with DoD's Joint AI Center, the JAIC, where we're sharing ideas on best practices. I know you've also been thinking quite a bit about ethics and responsibility in your role, Cheryl.
Yes, absolutely. And I think it's a critical role for us as a new office in AI and addressing AI across the entire enterprise. And we have been looking at the ethical principles that were published by the Department of Defense, also by the intelligence community. And so that is something that we're going to stand up here is an effort to review ethical principles and even more importantly, what you mentioned, which was more where you get towards the governance part, right? The policies. So, we can all say, easily adopt a set of policies, right? But I think what's important is that we also say, because we believe in these policies, we are going to also follow these rules and these standard processes in how we create AI and how we develop it, and then how we deploy it as well, and how we share it. So some things that I think about, and they also this ties in with adversarial AI. Something that we're also starting an effort up is to address adversarial AI. But one aspect of that we can address through ethical principles is this. I think about our data, and I think about our algorithms, and have we really reviewed the data and made sure that we understand the data, the provenance of these data, and do we have a way to monitor changes to these data? Do we have a way that that can be recorded? And then do we have a way to check that that data has not been changed other than in the way that we recorded and by the one who approved it? So, and I think that is one way. If we can begin these processes, then we can also address the ethical aspects of it and have additional questions, basically like a checklist, where you would say, has this been checked for various types of bias, and how was it checked? What kind of other tool or approach did we use to check it for bias? And then the same thing with the tool. How was the tool trained on what data sets, and have we really done some thorough testing on the tool to make sure that it's not biased in any way? And so I think of that as also really addressing the ethical principles, but then I also think of it as being good hygiene and also security. That this can also address some of the problems that we can encounter from adversarial AI, where they actually are an adversary is actively planting an attack inside of our data or in our algorithm, or somehow has corrupted the data.
Yeah, on that topic, it's a rising concern to just share with the audience that these are new vulnerabilities that come with the reliance on AI technologies. While there's great power that come with appropriate and insightful applications of AI, AI technologies also provide or lead to new weaknesses or attack surfaces that can be exploited by state and non-state actors, by hackers, for example. And it's been interesting to see the rise over the last 5 to 7 years or so of a whole field called adversarial AI that looks at what can be done to impede or confuse AI systems or get them to spill out important information. And also how, once we understand that, we can also develop robust AI techniques that can thwart or minimize these kinds of attacks. So yeah, it's great to hear that the DOE is excited and interested in focusing on this area, because we have to get this right to get the best out of the AI systems. Well, Cheryl, it's always great to talk. Oh, sorry, go ahead.
Jump in just to say that not to be confused with cybersecurity too. I think there's overlapping area here. And also, we can learn a lot in cybersecurity for AI, and also AI supports cybersecurity. But I think that also adversarial AI is an area where we need to do a lot of education around it and create new principles and new processes and methodologies to address it.
Thanks, Cheryl. Well, Cheryl, I was going to say, they never give us enough time for these kinds of sessions, so I'll have to continue our dialogue in one-ones, which I look forward to. It's been great hearing your thoughts today. Thanks for your leadership at the Department of Energy. It's great to have folks like you in leadership roles like the one you're at DOE. So thanks so much. And we're going to have to, for the clock here, I'm looking at, throw things back to our host, Romanita. Thank you, Cheryl.
Thank you for inviting me. It was a true pleasure. Thank you.